if we are working with categorical variables, then the basic scheme is, again, we need to think about how can we convert our categories in some numerical property, and then we apply our numerical testing scheme. Okay? I give you an example. Very often it's easy to convert your categories into something that's a proportion. For example, we have here a sample of 5 students, and one data we could sample is the gender. Yeah, so we would have 3 female and 2 male. That's basically our categorical variable. And we could convert this into numbers when we say, okay, it's 3/5 is the male as the female fraction, and the 2/5 is the male fraction. Yeah, so that's we are trying to convert these categories into numbers, and I will demonstrate this in here in this example. And if we do this, it's always a decision between in the category or not in the category. It's always only 2 cases, yeah? Which makes it a binomial distributed property, because it's again either yes or no. And we are testing against the binomial distribution. And we know that the binomial distribution approaches the normal distribution with a mean value of n times the success probability and a standard deviation of n times success probability times anti-success probability and the square root. Yeah, this normal distribution is where the binomial distribution approaches to, so that's where we do our hypothesis tests against. So example, let's say we know that around 70% of all the stars are member of a multiple system. So not a single star like the sun, but double stars, triple stars, or whatever. Now we select randomly 200 stars, and what is the probability that in our sample of 200 stars we will have at least 90% that are part of a multi-star system? So we know say again? The success probability, thank you, is 70%. Yeah, that's the property of the population. We have n 200, and we are asking what is the probability to get a mean value of p in our sample larger than 0.9. So we are having, again, we need to check the conditions. So independent sample size, and in order for the binomial distribution to approach the normal distribution, n times p needs to be larger than, what was it, 10? I think 10. Okay, I have to look. We have to look this up in the notes. So it needs to be large enough. Yeah. So the expectation value needs to be high enough. So that means we know that the mean value of our sample will be normally distributed with these properties. From our sample we can compute the C statistic. So that's 0.9, that's our observation, minus the population number, 0.7, divided by the standard error, gives us a C of 6.7. And that's basically 0, because it's almost 7 standard deviations away in a standard normal distribution. So there is a very low chance to actually find as many. Yeah? So, and what we did again, we are converting a category, yes, member, or no, not member, into proportions. Yeah?